I'm Tim. This PCBSync.
Have you noticed that the ESP32 needs 50 ohms, Bluetooth needs 50 ohms, GPS needs 50 ohms? So is it 50 ohms or 50 liters? So here's the question. Just how wide is 50 ohms really? Today, we'll use 3 free tools to show you directly. Let's first look at the KICD design calculation tool. So we enter the FR4 dielectric constant value. We'll use 4.2. The board thickness is 1.6 and the copper thickness is 35 microns. So let's do the calculation and see. The width it gives is 3.13 millimeters. A lot of people, wouldn't you be surprised seeing this for the first time? 50 ohms actually needs to be this wide. 3 millimeters is indeed a pretty wide trace. Next, let's look at another tool, Setter PCB. This tool has a lot of features, and we'll use its calculation function, the trace width function. We'll use the same parameters as before. Dielectric constant 4.2, FR4 material, copper thickness 35 microns, board thickness 1.6 millimeters. But this tool isn't as convenient as the one in KICD. Here, you have to input the width to display the impedance. For example, if I enter 3.3 here and hit enter, you'll see the impedance changes. 49.3. Our target is 50 ohms. So after trying several times, I finally found that 3.2 millimeters is the closest to 50 ohms. So in other words, the trace width calculated using this software is 3.2 millimeters. Finally, let's check with another online tool. There are many similar online tools like this. We'll enter the same parameters. Dielectric constant 4.2, board thickness 1.6. We also set the copper thickness to 35 micrometers and the frequency to 1 gigahertz. The tool has two functions. It can calculate impedance based on trace width or calculate trace width based on impedance. Right now, we want to find out the trace width. So we enter a target impedance of 50 ohms and calculate. It comes out to 3.107, which is approximately 3.11 millimeters. Now let's summarize the results. The result calculated by Tzad is 3.13 millimeters. The result calculated by the third-party PCB tool is 3.2 millimeters. The result from the online tool is 3.1 millimeters. At this point, many people will ask, why are there 3 different answers? It's because the calculation models are different, but the target is the same, 50 ohms. The difference is about 0.1 millimeters. This is actually completely normal, because some of them focus more on dielectric parameters, while others focus on things like copper flatness compensation and so on, so there will be some discrepancies. But as we can see, the margin of error in the trace width is very small, all within 0.1 millimeters. Finally, let me share an important tip. What truly determines the impedance is not the calculator, but the stack of parameters. If you get the board wrong or the stack up wrong, or if the dielectric constant is incorrect, even the most advanced software won't be able to save you. So don't get hung up on whether it's 3.11 or 3.2. The first thing you need to do is confirm the stack up before calculating the trace width. As we discussed in the previous 2 episodes, even with the same FR4, the dielectric constant can vary greatly. You must confirm this with the PCB manufacturer first. What is the exact value of the dielectric constant for FR4? For this kind of PCB, there won't be any errors reported by the software, but in the real physical world, problems will definitely show up. Thank you for watching.